I just ended that video. In fact, we do have another practice problem to do, and we need to do it. It's the K, S, P, and Q one, will of precipitate form. Definitely need to go through this problem together. So, sorry, that little too quick of a yay, huh? All right, so go back to the same worksheet. We just need to do that very last question. Okay, come on. Sorry about that. Here we are again. What we did not do was number 4. You might have thought you got away with it, but not this time, guys. Okay. I am going to maybe rewrite some of that. Actually, let's see, I've got some of it here. So I want to make this really nice and neat because it's pretty intricate. I see that I have 150 milliliters of a 0.00395 molar barium chloride. And I also have 550 milliliters of a 0.00775 molar potassium sulfate. All right. And the question is, will a precipitate form? All right. Will a precipitate form? So we need to solve for Q and compare to KSP. I'm assuming we have a KSP value here somewhere. Yeah, so I've got KSP equals 1.1 times 10 to the negative second. Okay, now, what are we going to have reacting? We're going to have barium chloride plus potassium sulfate, aqueous, aqueous, and we will get barium sulfate and potassium chloride. This will be dissolved alkaline earth metal. This will be a precipitate. Now, this, we need to see, will we actually have a precipitate? Do we have enough there to precipitate? So we now need to take this and go like this, all right? Got it? Okay. What we should do now, right, is we know that KSP is equal to Ba 2 plus, SO4 2 negative. But now we need to solve for Q. But in order to solve for Q, we need to know our concentrations, right? So we also need to solve for Q. And then we're simply going to compare Q to K. And then we're good to go. So for barium, guys, I'm going to use this information, right? So let's go ahead and look at that. And I'll use some pretty purple color. I've got 0.150 liters. I see that 1 liter is 0.00395 moles. And I see that 1 mole of the compound has 1 mole of barium ions. All right, so 0.15 times that is 0.05925. This is 0.05925 moles barium ions. All right, now I'm going to do the same here. I'm going to get, I need to know how many sulfates I have, right? So I will use this information here. And I will go, let's get a different color. Let's do green. 0.550 liters. Every 1 liter is 0.00775 moles. It's moles of the compounds. And every 1 mole of the compounds has 1 mole of sulfate. All right. So that is going to be equal to 6.09 times 10 to the negative no, 4.26 times 10 to the negative third. Okay, now I need you to notice something. What we need for our KSP and our Q is not moles. It needs to be concentration, all right? So all of these were added together, correct? They were combined, and we had 150 milliliters of this, and we had 550 milliliters of this. So we have a combined total concentration of 700 milliliters. Actually, my sig figs there are wrong. 700 milliliters, which is 0.700 liters. So we need to get that volume and use it to get our molarity. So we need to divide both number of moles by the 0.700 liters. I would go ahead and do it. At some point, you've got to do it. You can use ice charts with moles, but you don't want to forget to do this part. So when we do this, we get a concentration of barium that's going to be, hold on, I'm just making sure I'm looking at the right numbers here. 8.46 times 10 to the negative fourth. I hope that I'm seeing the, I'm pretty good at plugging things in. At labeling my work. And what we get here should be 6.09 times 10 to the negative third. So those are our actual concentrations. And that is what we need to plug in here and here, okay? So this is 8.46 times 10 to the negative fourth. And this is 6.09 times 10 to the negative third. Q is equal to those multiplied together. I'm just writing everything because it's a lecture, if you will. 6.09 times 10 to the negative third. Q equals, I've got that right here, 5.15 times 10 to the negative sixth. So I'm going to compare Q. Remember, the question is, will a precipitate form? Okay. Did that go across my screen the whole time? The question is, will a precipitate form? Q is to the negative sixth. K is to the negative 10th. Q is greater than K. That's so ugly. Q is greater than K. We will shift left, forming more of the solid. Need less ions to establish equilibrium. Therefore, yes, a precipitate will form. I really like this right here. Okay, it shows that you understand what's going on. You're just not looking at a value of Q. We need less of this, so therefore we're going to get more solid. If Q was greater with less than K, then we would need more ions to establish equilibrium, and we could put that into our answer. All right. Okay. See you guys later.